Hi everyone, welcome to our channel. Let's learn at leisure. In this video, we are learning about the exponents and powers of class 8, and this is the third part. If you haven't seen the first and second part, it is right there at the right top of your screen. So let's move on to the third part. But before moving to the third part, let's have a slight recap of last two parts. In part 1, we have learned the meaning of exponents and power is the combination of exponent and base, whereas exponent is not called as power. In part 1, we even learned the laws of exponents under multiplication, division, and exponents at 0, and we have converted large numbers, that is usual form, into exponential form, that is standard form, and we have solved some of the questions of exercise 2.1. In part 2, we have learned how to make the bases same if the base is not a prime number by factorizing it. In, and we have even solved some of the questions of exercise 2.1. So now let's revise some of the laws. So it would be better if you memorize these laws. A raised to the power of m into a raised to the power of n is equals to a raised to the power of m plus n. If the bases are same and the exponents are different, in multiplication you have to add them. Let's take an example, 3 raised to the power of 3 into 3 raised to the power of 2. So this will be equal to 3 raised to the power of 3 plus 2. Now let's go to the second one. A raised to the power of m whole raised to the power of n is equals to a raised to the power of mn. So when there is a power and again it is raised to another exponent, then we have to multiply those exponents. Let's take an example, 3 raised to the power of 3 whole raised to the power of 2, which is equals to 3 raised to the power of 3 into 2, that is equals to 3 raised to the power of 6. Let's move to the third law. A raised to the power of n into b raised to the power of n is equals to a into b whole raised to the power of n. So when there are same exponent but the bases are same, then we have to group the bases and add the common exponent out. So let's take an example as 3 raised to the power of 2 into 4 raised to the power of 2, and this is equals to 3 into 4 whole raised to the power of 2. So this is equals to 12 raised to the power of 2. Let's move to the fourth one. A raised to the power of n divided by a raised to the power of m. So in division, when there is a same base but the exponents are different, then you have to subtract them. In multiplication, you have to add them. 3 raised to the power of 2 divided by 3 raised to the power of 3. So this is equals to 3 raised to the power of 2 minus 3. Then this is equals to 3 raised to the power of minus 1. Now let's move to the fifth one. A by b or a divided by b whole raised to the power of n is equals to a raised to the power of n divided by b raised to the power of n. So when there is a division or a fraction whole raised to the power of n, whole raised to the power of any exponent, then we have to give that exponent to the number in the fraction, that is to the numerator and denominator. So let's take an example, 3 by 2 whole raised to the power of 3. So this should be done as 3 raised to the power of 3 by 2 raised to the power of 3. So let's move to the sixth one. A by b or a divided by b whole raised to the power of minus n. In the power, if the exponent is the negative, then you have to convert it into positive to solve the expression or to solve the problem. To convert the exponent into positive, you have to reciprocate the base. Let's take as 3 by 2 whole raised to the power of minus 6, and this will be 2 by 3 whole raised to the power of 6. Now let's move to the last law. A raised to the power of 0 is equal to 1. Any number raised to the power of 0 is always 1. 100 raised to the power of 0 is 1. 3 raised to the power of 0 is 1. 2 raised to the power of 0 is 1. 50 raised to the power of 0 is 1. Any number raised to the power of 0 is always 1. Now let's move to the now let's move to the now let's go to the next slide. Now let's see how to convert standard form to usual form and usual form to standard form. To convert standard form to usual form, standard form is m into 10 raised to the power of n, where m has to be less than 10 but greater than 1. But greater than 1. And usual form is a normal number like 0.003 or 3000. These are usual form and this form is called as standard form. So to convert standard form to usual form, we should check the sign of the exponent. If the exponent is negative, then we have to move the decimal point towards the left side. If you have a positive exponent, then we have to move the decimal points towards the right side. This is the only law used to convert standard form to the usual form. To convert usual form to standard form, we have to check the position of the decimal. Is the decimal at the right side or at the left side? If the decimal is at the right side, then we will have a positive exponent. If the decimal is at the left side, then we will have a negative exponent. This is the only law used to convert usual form to standard form, and this is the only law used to convert standard form to usual form. Now let's move to some of the problems of exercise 2.1. Evaluate 1 by 3 raised to the power of minus 1 minus 1 by 4 raised to the power of minus 1 whole raised to the power of minus 1. So first let's solve this power. 1 by 3 whole raised to the power of minus 1. So 1 by 3 whole raised to the power of minus 1 is equals to 3 raised to the power of 1 or simply 3, and 1 by 4 whole raised to the power of minus 1 is equals to 4 by 1 or 4 raised to the power of 1 or simply 4 itself. So instead of 1 by 3 raised to the power of minus 1, let's write 3 minus sign in between, and 1 by 4 raised to the power of minus 1, let's write it 4, and whole thing raised to the power of minus 1. So 3 minus 4 is minus 1 raised to the power of minus 1. So let's make it a positive exponent. So let's reciprocate the base, then this will be 1 by minus 1 whole raised to the power of 1. So 1 by minus 1 is equal to minus 1 itself. So the answer is minus 1 or minus 1 raised to the power of 1. So this is the answer for the first one. Let's move to the next one. 5 by 8 raised to the power of minus 7 into 8 by 5 raised to the power of minus 1. So let's solve this power. So 5 by 8 raised to the power of minus 7 is equals to 8 by 5 raised to the power of 7. So we got the base as 8 by 5. Surprisingly, the second base is also 8 by 5. So let's keep it as it is. So let's write it 8 by 5 raised to the power of 7 into 8 by 5 raised to the power of minus 1. Since the bases are same, let's write the common base out. Since there's a multiplication, let's add those exponents. 7 plus of minus 1. So this is equal to 8 by 5, 7 minus 1. That is equal to 8 by 5 whole raised to the power of 6. So for the second one is 8 by 5 raised to the power of 6. Now let's move to the next slide. 25 into t raised to the power of minus 4, 5 raised to the power of minus 3 into 10, 25 into t raised to the power of minus 4 divided by 5 raised to the power of minus 3 into 10 into t raised to the power of 8. In this problem, t is not equal to 0 as t is at the denominator. So if the t is not equal to, so if t is equal to 0, then the question is invalid. T should not be equal to 0 as it is even at the denominator. So your only prime number is 5. So we can factorize 25 and 10. So 25 can be written as 5 raised to the power of 2, and let's write t raised to the power of 4 divided by 5 raised to the power of minus 3 into this 10 can be written as 2 into 5. Since there is no exponent, don't need to write them in brackets, into 5 raised to the power of minus 8. Now we have here 5 as the base and t as the base. So let's write 5 to 5 raised to the power of 2, and this minus 3 will be minus of minus 3 when it moves at the numerator, and there is nothing, no exponent for the another 5 in the denominator. So if there is no exponent, the exponent will always be positive 1. So when this positive 1 moves here, this becomes minus 1 into t raised to the power of minus 4. So there is another t in the denominator. So this minus 8 will be minus of minus 8 divided by 2. So 5 raised to the power of 2 plus 3 minus 1 into t raised to the power of minus 4 plus 8 divided by 2. So this is equals to 2 plus 3 is 5. So 5 raised to the power of 5 minus 1 into t raised to the power of my 4 into t raised to the power of minus 4 plus 8, which is positive 4 divided by 2. And 5 raised to the power of 5 minus 1 is 5 raised to the power of 4 into t raised to the power of 4 by 2, which is equals to 5 into t whole raised to the power of 4 divided by 2. So this is the answer for the first one. Now let's move to the second one. Simplify 3 raised to the power of minus 5 into 10 raised to the power of minus 5 into 125 divided by 5 raised to the power of minus 7 into 6 raised to the power of minus 5. So in this question, 3 and 5 are only prime numbers. So let's write them. 3 raised to the power of minus 5 into 10 raised to the power of minus 5. 10 is 2 into 5. Since that is exponent, let's write them in brackets. Whole raised to the power of minus 5 into 125. 125 can be written as 5 raised to the power of 3 divided by 5 raised to the power of minus 7 into 2 into 3 is 6 whole raised to the power of minus 5. So let's remove the bracket. So this will be 3 raised to the power of minus 5 into 2 raised to the power of minus 5 into 5 raised to the power of minus 5 into 5 raised to the power of 3 divided by 5 raised to the power of minus 5 into 2 raised to the power of minus 5 into 3 raised to the power of minus 5. In this example, in this question, there is a 3 at the numerator, 3 at the denominator, 2 at the numerator, 2 at the denominator, 5 at the numerator, another 5 at the numerator, and a 5 at the denominator. So let's write them. So 3 raised to the power of minus 5, there is another 3 at the denominator, so this will be minus of minus 5 into 2 raised to the power of minus 5, another in the denominator, minus of minus 5 into 5 raised to the power of minus 5. Since there is another at the numerator, we have to add those exponents, plus 3, 1 at the denominator, minus of minus 7. So this is equal to 3 raised to the power of minus 5 plus 5 into 2 raised to the power of minus 5 plus 5 into 5 raised to the power of minus 5 plus 3 and plus 7. So this is equals to 3 raised to the power of 0 into 2 raised to the power of 0 into 5. So 3 plus 7 is 10 and 10 minus 5 is 5. This is equal to 3 raised to the power of 0 is 1. Any number raised to the power of 0 is 1 into 5 raised to the power of 5. So the answer is 5 raised to the power of 5. The answer for the second one is 5 raised to the power of 5. Express these numbers in standard form. Standard form is m into 10 raised to the power of n, where m has to be less than 10 and greater than 1. So let's move to the first one. So before moving to the first one, let's before moving to the first one, let's write the law to start. So before moving to the first one, let's write the law to convert usual form into standard form. To convert usual form into standard form, we have to see the position of the decimal. If the decimal is at the left side, then we will have a negative exponent. If the decimal is at the right side, then we will have a positive exponent. This is the only law used to convert usual form into standard form. So let's move with first one. Here the decimal is at the left side, so the exponent will be negative. Now let's see how many places we have to shift. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. 8.5 is yes greater than 1 and less than 10. So value of m is 8.5 into 10 raised to the power of minus 12. Now, now let's move to the second one. Here the decimal is at the left side, so the exponent is negative. Let's see how many places we have to shift. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12 again. 9.42 is just greater than 1 and less than 10, so value of m is 9.42 into 10 raised to the power of negative 12. Now let's move to the third one. In third one, we don't have a decimal point. If there is no decimal point, then we have to assume a decimal point at the end of the number. So this is point 0. Since the decimal is at the right side, then we will have a positive exponent. So let's see how many places. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. 6.02 is yes less than 10 and greater than 1. So it is 6.02 into 10 raised to the power of 15. Let's move to the fourth one. In fourth one, there is a decimal point, but it's at the left side, so we will have a negative exponent. Let's see how many places it has to shift to get the value of m. It's 1, 2, 3, 4, 5, 6, 7, 8, and 9 places. 8.37. So we have shifted 9 places, so the value of m is 8.37 into 10 raised to the power of negative 9. Let's move to the fifth one. In fifth one, there is no decimal point. So if there is no decimal point, we have to assume a decimal at the end of the number. Since the decimal is at the right side, we will have a positive exponent. Let's see how many places it has to shift to get the value of m. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. If it moves 10 places, it will have 3.186. So 3.186 is just greater than 1 and less than 10 into 10 raised to the power of 10. Let's move to the next slide. Express in usual form. Now we express those numbers in standard form. Now we have to express in usual form. So to express from standard form to usual form, we have one law, that is check the sign of the exponent. If we have a negative exponent, then the decimal has to be at the left side. If we have a positive exponent, then the decimal has to move towards the right side. So in the first case, we have a negative exponent, so the decimal has to move towards left side. Since there is already a digit before the decimal point, so let's subtract it. So this will be 6 minus, there's only one digit, so 6 minus 1. So 6 minus 1 is 5. So 5 is the count of zeros. How many zeros we have to put after the decimal point? So this will be 0 point. Now the count of 0 starts 1 0, 2 0, 3 0, 4, 5 and 3 0 2. And this is the usual form for the standard form. So let's move to the second one. In this case, we have a positive exponent, so the decimal has to move towards the right side. But there is already a place acquired at the right side, so let's subtract that place. 4 minus 1, it is 3, and 3 is the count of zeros. We have to add in that, so 4, 5 and 3 zeros, 1, 2, 3.0, and this is the usual form of the 4.5 into 10 raised to the power of 4. In third one, we have a negative exponent, so the decimal will move towards the left side, but there is no decimal in the value of m. So if there is no decimal, assume a decimal at the end of the digit. So 3.0 into 10 raised to the power of minus 8. So there is already a place acquired before the decimal, because we have to shift the decimal towards the left, but there's already a place acquired at the left side. So let's subtract that. 8 minus 1 is 7, so this is the count of zeros, so this will be 0 point. Now the count of zeros starts 1 2 3 4 5 6 7 and the number 3. So this is the usual form of 3.0, or simply 3 into 10 raised to the power of minus 8. Let's move to the fourth one. 1.0001 into 10 raised to the power of 9. 9 is a positive, so we have to move the decimal towards the right side. But there are so many places which are already acquired. So let's see how many places. 1, 2, 3 and 4. So we have to do 9 minus 4. And 9 minus 4 is 5. So we have to first write this number 10001, and we have to add 5 zeros, 1 2 3 4 and 5 and point 0, so that it becomes a decimal number. And this is the usual form of 1.0001 into 10 raised to the power of 9. Let's move to fifth one. 3.61492 into 10 raised to the power of 6. 6 is a positive, so the decimal will move towards the right side. So, but there are so many places occupied on the right side, so let's count them. 1 2 3 4 5. So it is 6 minus 5. This is 1. 6 minus 5 is 1, so we have to put only 1 0 after the numbers. So 361,492 and 1 0 at the end of the number. So 361,492 is the value of the 3.1492 into 10 raised to the power of 6. Now let's move to the next question. Express the number appearing in the statement in standard form. That means all these statements are in usual form. We have to express them in standard form. And standard form is m into 10 raised to the power of n, where m is less than 10 and greater than 1. So let's move to the first one. 1 micron is equal to 1 by 10 lakh meters. So 1 by 10 lakh meters is 0.0000001 meters. So the 0.0000001 meters is in usual form and we have to convert this into standard form. Since the decimal number is at the left side, we will have a negative exponent. So let's say how many places it has to shift. 1, 2, 3, 4, 5, 6. So this is negative 6. So 1.0 m has to be equal or greater than 1, not only greater or equal to 1, but it has to be less than 10. So this is 1.0 into 10 raised to the power of minus 6. Now let's move to the second one. Charge of electron is 0.000000000000000000016 coulombs. So let's convert this such a small usual number into a standard form. So since the decimal is at the left, we will have a negative exponent. So let's see how many places it has to shift. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, and 19 places. So this is 1.6 and 1.6 is greater than 1 and less than 10. So this is 1.6 into 10 raised to the power of minus 19. So let's move to third one. Size of bacteria is 0.0000005 meters. It's such a small number. So let's convert it into standard form. Since it is at the left side, we will have a negative exponent. Let's see how many places it has to shift. 1, 2, 3, 4, 5, 6, and 7. So 5 is greater than 1 and less than 10. So the value of m is 5.0 or simply 5 into 10 raised to the power of minus 7. Let's move to the fourth one. Size of a plant cell is 0.0000127 meters. So now let's see how many places it has to shift to. The decimal is at the left side, so we will have a negative exponent. Let's see how many places it has to shift so that we get the value of the exponent. 2, 3, 4, and 5. 1.275 is just greater than 1 and less than 10. So it is 1, 2, 3, 4, 5 places, and the value of m is 1.275 into 10 raised to the power of minus 5. So the size of a plant cell is 1.275 into 10 raised to the power of minus 5. Now let's put the fifth one. Thickness of a thick paper is 0.07 millimeters. So this is a negative exponent as the decimal is at the left side. As the decimal is at the left side, how many places? It's just 2 places. 7.0 or 7 point something. 7 is just greater than 1 and less than 10. So it has moved 2 places. So value of exponent is 2. And value of m is 7. So 7 into 10 raised to the power of minus 2 is the answer for our fifth question, that is thickness of a thick paper. Now let's summarize what have we learned in this session. In this session, we just took a slight recap of last two parts and we have memorized some of the laws and we have learned the conversion of standard form to usual form and their meaning, and we have solved some of the questions of exercise 2.1 and 2.2. So meet you in the part 4 of exponents and powers, and that is the last part of this chapter. So keep watching, keep smiling, and bye.